This video is going to be strictly examples of using this process of separating and integrating, and then we'll finish with a video that takes you through some of the delta math types. So this next one, couple things with it. First of all, if you see y prime, I love writing y prime for the derivative, but in this section where you're separating and integrating, it's actually not helpful. So when you're doing something like this, you want to rewrite it so that it is in terms of a dy over dx, because you actually physically have to separate that as well. The only thing that needs to move in this case is the dx. You're going to multiply both sides by it. So you're going to get dy over y, or you could write it as 1 over y dy equals 3x dx. It is now fully separated. The integral of dy over y is a natural log of y. Think of it as like a du over u, or like a 1 over x. This is a 1 over y. The integral of 3x is 3x to the second over 2. So the left side was a natural log integration. The right side was just a power rule. This is a very specific type of simplifying, so I'm going to really take my time on this one. When you have something as a natural log of y and then everything else on the other side is x's, they will never let you leave that as a final answer. You will need to solve for y by exponentiating. So what that means is both sides will be written as base e. That will cancel the natural log. So then you'll have e to this whole power. Everything is the power here. Not only the 3x squared over 2, but also the plus c. So you have this entire power. They won't let you leave it as that either. So let me kind of show you a little exponent rules here. So e to the x squared over 2, e to the 3x squared over 2, plus c is the same as saying times e to the c. I'm using exponent rules kind of in reverse. The idea that if I multiply bases, I can add exponents. So if I have exponents then added, I can actually multiply your bases. E to the c is a constant. E is a constant, c is a constant. If I take e to a constant power, you're going to get another constant. So your final answer, I'm going to write up high so you can see it, is you have a constant and then this e to the 3x squared over 2. This will be required simplifying on any sort of free response, or even in a multiple choice, you'll see this done, where you have to get your y by itself, and we do have to write it as a c as like actually the coefficient. It's going to happen several times in this video, so if that first time doesn't make sense, it'll get better. All right, so the next one is actually really similar. I'm going to divide by y on this side, and I'm going to multiply by dx on this side. So I'm going to have dy over y equals 3x squared dx. We have separated, so now we integrate. Usually on a free response, you get 1 point just for separating, even if you have absolutely no idea how to integrate it. The integral of the y side is a natural log of y again. The integral of the x side ends up being x cubed. On a free response, if the integration is hard, they often give you 2 points, 1 per side. So if you figure out one side and not the other, you still get a 1 point. If it's really easy integration, they will only give you 1 point for the final integrated step. They will give you multiple points for the simplifying and understanding how to go from here. So again, I need to exponentiate, which is going to give me y equals e to the x cubed plus c. But then again, that can be written as e to the x cubed times e to the c, and e to the c is a constant. So your final answer is c. I started writing it wrong. Your final answer is c e to the x cubed. And if you don't get y by itself and do that simplifying, they would not give you full credit on a free response. Next one, we need to get my y on this side. We need to get the x and the dx on this side. So we're going to have dy over y equals, when I multiply by dx and divide by x, I'm going to get dx over x. One general comment, you can't have your dy or your dx as part of the denominator. So if you separate and you get something like this, it is perfectly legal to flip each side of a fraction when you have a proportion, and that will get you to what you need here. But yeah, you can't have a dy or a dx in the denominator. So when I integrate both sides end up being a natural log. You get the natural log of y on this side, and you get the natural log of x on this side. When you exponentiate, here's what's going to happen. That's going to cancel. You're going to have e to the natural log of x times e to the c. E to the c is just a constant, and then e to the natural log of x is just x. This actually gives you one of the most simplistic separated solutions that you'll run into. Finally, a couple more. This next one's a little messy, but I want to show you some of the ways that we can kind of deal with the messiness. First thing is I have multiple y's in the denominator here. I'm actually going to need to factor one of those y's out, and that will help the process of separating. So I'm going to pull out a y, leaving me with 1 plus x squared. I'm going to multiply by y on the left side, and I'm going to multiply by dx on the right side, and then integrate each side. This is one where the y side is very simple. The x side might be a little confusing for you. So the y side is just y to the second over 2. The x side, you may try a u sub with this. That's usually the first thing students try, is to let u be the bottom, u to be 1 plus x squared. But the problem is the derivative of that is 2x, and you don't have an x in the numerator. So this is not a u substitution. This is actually an inverse trig. It is arctangent because it's addition and no square root. It is the arctangent of just x over 1. So arctangent of x. When you have things like that that are more complicated, you most likely will not be asked to get y by itself. You may be asked to multiply by 2, so you may see something like this. But most likely, they will ask for very little simplifying because the integration was more complicated, which gave you a more complicated general solution. And then finally, I do want to show you that trig can show up with these, usually basic trig, lots of sines and cosines. So we can separate by cross multiplying. So we have cosine y dy equals sine of x dx. Integrate both sides. The integral of cosine is positive sine. The integral of sine is negative cosine. Trig is another example, trig and inverse trig, of when they would not ask you to get y by itself, because to get y by itself, you'd actually have to use the inverse sign. What you may see is they may put all the trig on one side, so you might see the cosine added to the other side, but they will not ask you to do extra simplifying. So sometimes the trig looks like it's going to be worse, but because of the not needing to simplify, it's a little bit easier. I'm going to do one more video that goes through and talks how to work with the delta math problems, but this gives you a little more idea of what we're going through today.